Good morning, children. Let us start NEET from organic section. As already one topic has been completed in the previous 2 weeks, solution topic. Let us move to the first topic from organic section, haloalkanes and haloarenes. Haloalkanes and haloarenes. Haloarenes. Before going to the topic, we will discuss that how the marks are going to be distributed in the NEET paper. Recently, that is a 2020 paper, but I have seen that approximate 45% of the question paper, approximate 50% we can consider, including first year and second year together, 50% of the paper is organic chemistry. It means that when they are giving the more preference to the organic chemistry, we too need to concentrate much on organic chemistry. And remember one thing, organic compounds or the organic chemistry, we cannot say that the first year is separate or the second year is separate. If we'll see the complete the complete question paper, the question is going to start from first year, but it will be end by second year portion. And in that second year portion, you might have seen that we are going to start from the reaction from haloalkane, but we are going to end with organic compound containing nitrogen. So what I mean to say that in organic chemistry, conversions are most important. Conversions. How to convert one organic compound to other organic compound. And remember one thing, during conversion, if we are having same functional group, during this one, functional group may be same or functional group may be different. Have you remembered, children? During the conversion, we can say that sometimes we are getting the same functional group, sometimes we are getting different functional group. And even in that conversion also, you might have seen that during the same functional group or different functional groups, we are going to ascend the series. Means what? We are going to increase the number of carbon atom. Either we are going for ascending series, or sometimes we are going descending series also. Ascending means what? Where lower hydrocarbons are converted into higher hydrocarbon, whereas the descending means what? Higher are converted into lower hydrocarbon. This is increasing order and this is decreasing order. All these conversions are possible. It means that whenever we are dealing with organic chemistry, we cannot say that as we are reading haloalkane and haloarene, don't think that these questions are going to ask only with respect to haloalkane and haloarene. They may ask from organic compound containing up to nitrogen also. Means haloalkane or the haloarene may be converted into alcohol. Alcohol may be converted into alkyl halide. Aldehyde. Aldehyde may be converted into carboxylic acid. Even they can convert it into amine or the organic compound containing nitrogen. That means that when we are dealing with such conversion, let us take alkyl halide can be converted into alcohol. Alcohol can be further converted into aldehyde. Aldehyde can be further converted to carboxylic acid, which are lastly converted into amine. Don't think that reaction is possible only in a forward direction. It is possible in opposite also. But the reagent must be proper, suitable reagent. What we can say, children? Suitable reagent. Reagent must be proper. While converting this one, have you remember that alkyl halide can be converted into alcohol by different way, like aqueous potash, aqueous sodium oxide, moist silver oxide, but most preferably is moist silver oxide. Like that, alcohol on oxidation gives aldehyde. Aldehyde on further oxidation gives carboxylic acid. Carboxylic acid on schematic reaction converted into amine. It means that we can increase the number of carbon atom also, we can decrease the number of carbon atom also, we can keep the same functional group, or we can make a different functional group. So what I mean to say, the total summary, that organic chemistry, it cannot limit like physical or inorganic chemistry. It is very vast. That's why they are separated as this one, a compound of carbon and their compound. They are separated as organic chemistry as a separate branch. Why it is so? The reason is this only. It is endless. We cannot end. We cannot end. During the synopsis, as today I am going to start with the synopsis. Remember one thing, in the synopsis, in between, we'll go with in-text questions. And other than that, we are not going to take a single word also other than NCERT. Okay? I'm not going to take any of them, because when they are not going to ask any question other than NCERT, then why we need to concentrate? Because according to the NTA, they have given the direct this one, that a statement that all the questions, all the content of the NEET or this one, even for the JEE also, they are not going to ask other than JEE mains. It will be only from the NCERT. That's why we'll concentrate only on NCERT. But in between, as I said earlier, we'll go for the questions also along with synopsis. Questions that too from NCERT. I'm not going to take other than NCERT. Okay? Let us move to the topic, haloalkane and haloarene. This is a brief idea or the summary of the topic, that summary of the organic chemistry, that how the questions are going to be framed, how the conversions are going to be framed. Let us move to the topic, haloalkanes and haloarenes. Synopsis along with question paper discussion. Let us move to the first synopsis. And when we are discussing the synopsis, it is your duty that after completing every topic, you need to prepare. That complete synopsis you read once, complete this one, and even the MCQ can solve, which are based upon NCERT. Let us move to the topic, haloalkanes and haloarenes. Synopsis. As we know very well that the name itself indicates haloalkane and haloarene both are IUPAC name. According to the common system, haloalkane, if you'll see the haloalkane, they are called as what alkyl halide. Haloalkane, common name. Haloalkane, common name is alkyl halide. Whereas haloarene, common name, phenyl halide. Phenyl means what, children? C6H5. C6H5 is called as phenyl. The C6H5 is called as phenyl. As we are going to call methane to methyl. Okay, alkane to alkyl. Alkane, one hydrogen atom is removed to get alkyl. Same way from benzene, if we are going to remove one hydrogen, we'll get C6H5 as phenyl. C6H5 as phenyl. Now the question arises that what is haloalkane and haloarene? If we'll see the name itself indicates that haloalkanes are the derivatives of alkane. What is haloalkane? Haloalkanes are derivatives of alkane, where one or all hydrogen atom can be replaced by halide. Haloalkanes Haloalkanes are the derivatives of alkane. What are haloalkane, children? These are derivatives of alkanes, where one or all hydrogen atoms replaced by halide group. Replaced by halide group. Replaced by halide group. Then what are haloarenes? Haloarenes, name itself indicates that they are the derivatives of benzene, where one of the hydrogen atom of benzene, one or remaining also, because which are the electronic effect that we'll see later. They are replaced by benzene. These are the derived from benzene, where one of the hydrogen atom are replaced by X halide. Even remaining are also possible. Based upon the electronic effect, these are ortho-para directing in nature. That we'll see later. Now, if we'll see the haloalkane, hydrocarbon RH treated with X2 minus of HX converted to RX. Okay, hydrocarbon. These are saturated hydrocarbons. These are saturated hydrocarbons converted to alkyl halide. Saturated hydrocarbons are converted into what, children? Alkyl halide. Even you can call it as haloalkane also. In case of the benzene, on halogenation, minus of HX converted into haloarene. Both are the conditions. In one, saturated hydrocarbons are converted into haloalkane or the alkyl halide. Here, benzene are converted into converted to haloarene. Benzene converted into what, children? Haloarene. But the conditions are different. What are those conditions? Tell me. This is possible in presence of UV light. But this is possible in presence of Lewis acid. Because Lewis acid acts as what, children? Halogen carrier. Lewis acids act as what? Halogen carrier. So remember one thing. Here in this case, substitution takes place where H is replaced by X. This is also a substitution. But this substitution takes place in presence of halogen carrier or in presence of Lewis acid. These are called as what? Electrophilic substitution reaction. Have you remembered, children, what are Lewis acids? Lewis acids are one which have the capacity to accept electron. It means that they themselves are electron deficient species. That's why, have you remember that? Generally we'll say in the equilibrium topic we have studied about Lewis acid. What we said over there? Lewis acids are usually electrophile. Why they are called as electrophile? Because those are electron loving species or those are electron deficient species. Now, not only haloalkane and haloarene, even haloalkene and haloalkane also possible. Our topic is related with haloalkane and haloarene. Doesn't mean that only haloalkane and haloarene are possible. Even haloalkenes also possible. Even haloalkenes. Means what? This is a chain of carbon-carbon, single bond, double bond, all will be there. So it means that whenever the halide group is in a chain, it is present which contain carbon-carbon double bond. They are called as what, children? Haloalkene. Similar way, haloalkane. Similarly, what? Haloalkane. As in the syllabus, we are having polyhaloalkane and haloarene. That's why we are least to bother about haloalkene and haloarene. Haloalkene and haloarene. This is all about how the definition of haloalkane. So remember one thing, whenever we are defining the name haloalkane, we can remember that haloalkane Haloalkanes are the derivatives of alkane where one or all hydrogen atom are replaced by water halide group. And these are possible, as I said, that hydrocarbon by substitution reaction, that is halogenation reaction, chain reaction. This is actually called as free radical substitution reaction. This is called as what, children? Free radical substitution. This is free radical substitution. And this is called as electrophilic substitution. Electrophilic substitution. Therefore, whenever we are dealing with any reaction, what I said earlier in the introduction, that suitable reagent, suitable conditions are must. Without suitable reagent, without suitable condition, you cannot expect that the so and so molecule are converted into or change its functional group. Maybe substitution, maybe addition, maybe elimination, maybe any kind of reaction. Reagent T, suitable reagent T is must. And don't think that all the reactions are possible for all the molecule, because these reagents will be selective and substrate will also be selective. Substrate will also be selective. Let us move to the topic that why we are going to study this topic. Is there any reason? Yes, one of the important reasons that we are going to score marks. The second reason, the most important, why it is included in the syllabus, it has maximum applications. What are those applications? That means we'll go to the application, children. What are the applications are there? Means what are, why we are going to study this topic? What is the reason to study haloalkane and haloarene? Any topic, whenever we are going for any topic, necessary to concentrate, necessary to first bit to concentrate that why it is included in our portion. Is it a condition that we need to study this topic? Let us move to the topic, importance. What are the important applications of this topic? Importance, or we can call it as applications. Importance or applications. Do you know, children? Haloalkane and the haloarene, this topic, this has maximum medicinal application. Maximum medicinal application. Have you remembered that during First World War? Have you remembered, children? During First World War, many of the soldiers have become blind. Many soldiers have become blind due to carbonyl chloride, that is phosgene. This is used in the, what we can say, warfare. That is, soldiers have become blind. Have you remembered that time around 85% of casualties are due to the blindness of soldiers. And this phosgene, they have prepared from chloroform. They have prepared from where? Chloroform, CHCl3, chloroform. It has highly toxic and corrosive action. Have you remembered earlier days they used to prefer haloform as anesthetic agent. Anesthetic agent is what? Chloroform, but chloroform is toxic and carcinogenic. What do you mean by carcinogenic? Cancer-causing substances are called as carcinogenic. Okay, those are from the biology, they are knowing. Carcinogenic are the substances which are responsible to cause cancer. So in the First World War, they have used water phosgene. They have passed in the warfare, they have passed phosgene or the carbonyl chloride. How they have prepared carbonyl chloride? From chloroform. Even we are knowing that chloroform can be used as water anesthetic agent. It is anesthetic agent. but it is highly toxic and carcinogenic. That's why chloroform has been replaced by another anesthetic agent as halothane. What a halothane? CF3 CHCl Br. Halothane. Halothane. Halothane is used as anesthetic agent. So in the application, what we can say, or in the importance, one of the first important is we are going to start from the First World War. During the First World War, many of the soldiers have become blind in the warfare. Why it is so? Because they have used the phosgene gas over there, and that phosgene gas is prepared from chloroform. What is chloroform? Chloroform is actually anesthetic agent, but it is highly toxic and carcinogenic in nature. Okay, I think First World War is around 1918, maybe, as per my knowledge. So here, during that First World War, what happened? 85% of the casualties, around 80 to 85% of the casualties are due to this one. Casualties of soldiers are due to what? Blindness caused by phosgene. And the second one is chloroform. Earlier they used to prefer it as anesthetic agent, but later it has been discarded because it is toxic and carcinogenic in nature. It is replaced by halothane. CF3CHCl Br. Halothane. Next one. Not only this one, during this pandemic, you might have heard that HCQS. What is HCQS? Hydroxy chloroquine, hydroxychloroquine sulfate. Hydroxychloroquine sulfate. This is the drug which they have used in this pandemic, that is in the during the treatment of coronavirus. They have used hydroxychloroquine. Have you remembered, children? This is not only used for coronavirus, treatment for the coronavirus, even for it is used in arthritis. It is an arthritic drug, arthritis, or even we can call it as rheumatoid. Those are from the biology, they are knowing perfect spelling and all. Don't expect much biology from chemistry teacher. So here we can say that hydroxychloroquine sulfate, the tablet is HCQS. What is HCQS? Hydroxychloroquine sulfate tablet. And this is used for the treatment of pandemic, which we are using over here, that is coronavirus. Even it is a arthritic drug and rheumatic drug. It is used in the joints pain and all. Other than that, many of the antibiotic, like chloramphenicol or chloromycetin. Chloramphenicol. Do you know, children? During typhoid, the highest fever is during typhoid. And during typhoid, the treatment can be done by using chloramphenicol during typhoid fever. Other than chloramphenicol, even they can use the antibiotic as chloromycetin. Okay, even the analgesic like diclofenac. So it means that whenever we are dealing with any topic, we should know the importance of the topic. Don't think that they are having only medicinal application. Even the haloalkane or the haloarene, that is a derivatives of this one halide, even they are used as what a pesticide. You might have heard about DDT. Dichlorodiphenyl trichloroethane. Have you remembered, children, in case of the DDT, which is used as a pesticide? It is used as pesticide. But usage of long term of DDT has hazardous effect. But you know, children, even after having hazardous effect, even today in South Africa, they are using They are using DDT to kill the malaria, to avoid, or we can say that for the what we can say, to avoid the malaria. To avoid the malaria, they are using the pesticide as DDT. Other than that, even we can use chloroquine as an anti-malarial drug. Anti-malarial drug is what? Chloroquine. Chloroquine. So it means that applications of this topic is endless. If you'll see the complete, just in 1 minute I'll summarize. During the First World War, we have used phosgene, which is prepared from chloroform. Because chloroform on oxidation are converted into phosgene. Earlier they used to prefer chloroform as an anesthetic agent, but chloroform is highly toxic and carcinogenic in nature. That's why it has been replaced by halothane. What is halothane? CF3CHClBr. Then we have went with HCQS, which is used for the treatment of hydroxy. This one, coronavirus, even it is an arthritic drug, it is a rheumatic drug. Other than that, antibiotics like chloramphenicol. Chloramphenicol, we can say that it can be used in the typhoid fever. Even the chloromycetin, diclofenac, all these are what? They are having their own importance. Other than that, we can use even the pesticide as DDT. But the long term or the long usage of DDT has many hazardous effects. Even though today also in South Africa they are using DDT, because this one, to kill this one pesticide, they are going to spray the DDT over the long range of forest, because in South Africa, as we know that, they are having a major part of forest. Other than that, even the anti-malarial drug, which can be used as chloroquine. These are the, I have listed out some of the applications. Other than that, even you can say that lastly, it can be used as a solvent in many of the organic reactions. In this, most important part is related with phosgene and as well as what we can say, halothane. Because this is in the 2019, COVID-19 have started. You may expect in 2021 question related with HCQS also. Because usually while preparing the question paper, when they are dealing with the application, they'll take the recent update. That's why better to concentrate on HCQS also. This is all about the general introduction or the importance of the topic. Let us move to the topic, that is classification. How we are going to classify haloalkane. Let us completely, we will separate out one by one. We'll move to the topic, classification of haloalkanes. On what basis we are going to classify haloalkane and along with their examples. Whatever the applications I have given over here related with haloalkane and the haloarene, you read once and remember one thing. And other than that, as I said that HCQS they have not mentioned in NCERT book. Hydroxychloroquine sulfate, but it is a recent update. We can expect the question. in 2021. That's why I need to prepare. Phosgene they have asked many times. Even halothane also they have asked many times in the competitive exam. Classification. How we are going to classify the organic compound? Before the classification, we'll see that, as I said earlier, haloalkanes are RX. These are saturated hydrocarbon. These are haloarene, where the benzene is linked with X. As carbon and X, there is a lot of difference in electronegativity. Displacement of sigma electrons to its place towards X. X will get a negative charge. Carbon will get a positive charge. That's why X is substituent which has the character to withdraw the electron. X behaves as what? Electron withdrawing group. Therefore, negative inductive effect is possible. Whereas in case of this one, no doubt X is electron withdrawing group, but due to the, what we can say, movement of the electron or the delocalization between lone pair and pi electron. Everything we have discussed in the earlier topic. We need not to discuss much. That is a delocalization between lone pair and the pi electron, which leads to what? A positive mesomeric effect and positive resonance effect. It is what? It is a deactivating group. Deactivating group, but ortho and para directing in nature. Ortho and para directing in nature. In nature. Okay. If they are going to ask, one of the question is there in NCERT between benzene and chlorobenzene. Between benzene and chlorobenzene, which will undergo readily electrophilic substitution reaction. Readily electrophilic substitution reaction. The answer is benzene. Answer is benzene. No doubt it is ortho-para directing in nature. But what I said over here? Deactivating nature. It has the character to withdraw the electron from the benzene. It has the character to withdraw the electron from the benzene. But the delocalization takes place in such a way that lone pair of electron will be shifted the side, pi electron will be transferred. That means that whenever we are dealing with such a molecule, chlorobenzene, okay, lone pair of electron will be shifted over here, pi electron shifted to adjacent molecule, okay, adjacent molecule. Therefore, we'll get what, children? We'll get the resonating structure as like this. Resonating structure, again there is a delocalization and all. Everything we have written in the earlier theory classes. I need not to write much, but you can write the conclusion that these are ortho-para directing in nature. Okay, that's why this is the NCERT question between benzene and chlorobenzene. Let us move to what topic? Let us move to classification. On what basis we are going to classify the organic compound like water? That is haloalkane. How we are going to classify? Classification. There are different ways or the different factors are there on the basis of which we are going to classify organic compound like haloalkane and haloarene. Classification. Classification. On the basis of first classification is what? On the basis of number of halogen atom. Means on the basis of number of halogen atom. On the basis of number of halogen atom. X atom. X atom. They are classified as what? They are classified as mono alkyl halide. They are classified as what? Mono alkyl halide. Second one, dialkyl halide. Third one, trialkyl halide. Tetraalkyl halide. Simple way we can call it as what, children? Polyhalogen derivatives. Polyhalogen derivatives. Instead of writing tri, tetra and all, in a simple way we can call it as polyhalogen derivatives. Name itself indicates that whenever we are dealing with monoalkyl halide or the monohalogen derivative of alkane, we can call in a simple way that only one hydrogen atom is replaced by halide. only one of the hydrogen atom is replaced by halide group, they are called as monoalkyl halide. If two halogen atoms are replaced, they are called as dialkyl halide. On what we can say, three hydrogen atoms are replaced, they are called as trialkyl halide. Similar way, four are replaced. That's why in a simple, all together we can call it as, depending upon number of hydrogen atom replaced by halide group, they may be mono, they may be di, or they may be polyhalogen derivatives. Polyhalogen derivatives of what? Alkane. Polyhalogen derivatives of alkane. It doesn't mean that only we can classify haloalkane. Even we can classify haloarene also. Even we can classify haloarene also. If we are going to call it as haloarene, we can call it as monohaloarene. Even we can call it as dihaloarene. Okay? Trihaloarene. So it means that don't think that we are going to classify only with respect to alkane. Even the classification can be done with respect to arene also. That means that on the basis of number of halogen, remember one thing, how many hydrogens are removed, that many halogens should be added over there. To satisfy the valency, how many hydrogen atoms are removed, that many number of halogen atoms should be added over there to get a respective haloalkane. One is replaced by one halide, mono. One is replaced by two is replaced by two, it is a di. It means that not only with respect to saturated hydrocarbon, even with respect to benzene also. Even with respect to benzene also. That's why we can say that whenever we are dealing with monohaloalkane, because our topic is actually basically it is completely related with monohaloalkane and monohaloarene. That is, it should be containing only one, because when we are dealing with the method of preparation, physical properties, chemical properties, we are dealing with a completely monohalogen derivative. We are dealing with whatever only monohalogen derivatives, because polyhalogen derivative is eliminated from the revised syllabus. In the revised syllabus, we are not going to discuss with the polyhalogen derivatives. We are going to discuss only with respect to monohalogen derivatives. Okay. Now, if the topic is monohalogen derivative, we'll see that monohalogen derivatives are further classified. How they are going to classify them? See, here you can see, even you can write like this also. RCH2X. They are represented as what? RCH2X. Dihalogen, we can write it as RCHX2. They may be geminal, mesinal, that we'll see later. Even in the trihalogen, we can write it as RCX3. Even with the tetrahalogen, we can write it as what, children? We can write it as CX4. Same way, when we are dealing with the monohaloarene, only one of the hydrogen atom is replaced by halide group, or two halogen atoms are replaced by halide group, or three hydrogen atoms are replaced by halide group. This is all about general representation. Only to remember one thing, with general representation are perfect to you, examples you can write yourself. Because writing example and making the name is not so difficult, but remembering general representation is must. That's why whenever we are dealing with this one, always remember that only one halide group, two halide are there, three are there, poly may be possible. Same way, one of the hydrogen replaced by X, two are there, like that we are having three also. Even this will be ortho to each other, they may be para to each other also. But remember one thing, whenever we are giving the name, either the common name or the IUPAC name, as the topic itself is IUPAC name. Let us move to monohaloalkane in detail. Let us move to what? Monohaloalkane. I hope you people are this one understanding the topic. If any doubt, anything are there, you can post your doubt on WhatsApp. Monohalogen derivatives. Monohalogen derivatives. Monohalogen derivatives of alkane can be classified on the basis of different factors. Like first one, on the basis of nature of carbon atom. Second one, on the basis of nature of hybridization of carbon. That means that there are two ways are there to classify monohalogen derivatives of alkane. First one, on the basis of nature of carbon atom. Okay. Second one is on the basis of nature of hybridization of carbon. Hybridization of carbon. This is Roman number 1 on the basis of nature of carbon atom, and this is Roman number 2 on the basis of nature of hybridization of carbon. Let us move to one by one. Remember one thing, whenever we are dealing with on the basis of nature of carbon atom. First one, on the basis of nature of carbon atoms, they may be primary, secondary and tertiary. What we can say? They may be primary alkyl halide represented by 1 degree, secondary 2 degree, tertiary 3 degree. Remember one thing, monohalogen derivative of alkane, they are having general formula as what? CnH2n plus 1x. CnH2n plus 1x. So what we can say? They are classified as on the basis of nature of carbon atom. They are classified as what, children? Primary, secondary and tertiary. Alkyl halide. In a simple way, halide group linked to primary carbon atom are primary. Halide group linked to secondary carbon atom are secondary. Halide group linked to tertiary carbon atoms are tertiary. Correct? What are primary, secondary and tertiary carbon atom? One clue I will give it to over here. Carbon containing halide must have only one carbon. Carbon containing halide group must have only one carbon atom. Only one carbon atom. They are called as what? This is only one carbon atom. Remaining are what, children? Hydrogen. They are called as primary. Same way, carbon containing halide has two carbon and one hydrogen. They are called as what? Secondary. Carbon containing halide do not have any hydrogen. All the sides they are having 3 carbon. Is it clear to you? So what we can say? Primary alkyl halide are those where carbon containing halide group is primary in nature. Primary in nature. What is primary? How to identify primary carbon atom, secondary carbon atom, tertiary carbon atom? We have studied in first year. That's why we can say that whenever the carbon containing one carbon linked with halide, containing one carbon, even no carbon also, then the carbon containing halide, all the 3 are hydrogen. This is also primary, children. This is also primary. So what we can say? Carbon containing halide must have one carbon or no carbon. They are primary in nature. Carbon containing halide has 2 carbon or 1 hydrogen. It is secondary. Carbon containing halide has 3 carbon, no hydrogen. It is called as tertiary. Then primary carbon atom, primary alkyl halide. I write simple. Primary RX. They are represented as what, children? They are represented as RCH2X. Same way, secondary RX, RCX, R' and H. Similarly, tertiary alkyl halide, R, C, R dash, X, R double dash. R dash and R double dash. R dash, R double dash. They may be same, they may be different. It is not a condition that they should be same. They may be different also. If you go to the example, I'll write one by one example. Primary alkyl halide, simplest example. First example is CH3Cl, methyl chloride. IUPAC name is chloromethane. Even we can write it as CH3, CH2Br. It means that this carbon containing halide has 3 hydrogen. This carbon containing halide has 1 carbon. Okay, one side it is having 1 carbon. So remember one thing, either here they are having no carbon or here they are having 1 carbon, they are called as primary. They are called as what, children? Primary. Even if I am going to take the example, C6H5CH2Cl. This is also primary. This is also what? Primary in nature. Primary in nature. But remember one thing, this is called as R-alkyl halide. R-alkyl halide. This is called as mixture of aromatic and aliphatic. That's why it is called as R-alkyl halide. When we are dealing with such one, like the secondary examples, CH3, CH, CH3, Cl. Isopropyl chloride. C2H5 also we can write. Doesn't mean that R and R dash may be same, may be different. When we are dealing with the carbon atom 1, 2, 3, 4, 4 carbon atom are there. Second position bromo group, 2 bromobutane. We can call it as 2 bromobutane. So here, even this is called as secondary butyl bromide because I will show you over here what is normal, what is iso. After this example, I will show you. A tertiary alkyl, right? All these 3 may be same, may be different. If they are 3 also, we will take the example. If they are different also, let us take the example. This is tertiary butyl bromide. All the 3 are same. Not possible that all 3 should be same. They may be different also. It's 7. Correct? The longest chain is what? This one. This is the longest chain. How many carbon atoms are there? 1, 2, 3. 3 plus 3, 6. Correct? 1, 2, 3. 3 plus 3, 6. So what we can call 3 methyl. Okay, 3 iodo. The alphabetical order, I will come first. 3 iodo, 3 methyl hexane. 3 iodo, 3 methyl hexane. 3 iodo, 3 methyl hexane. Because whenever we are dealing with, where the children will get confused, I'll tell you one clue over here, one point over here, they'll get confusion over normal. Normal, it will be easy to understand a bit. Iso, when to call iso, when to call secondary, when to call tertiary, when to call NEET. Alkyl halide, that I'll tell you. So we can say that on the basis of nature of carbon atom, they are classified as primary alkyl halide, secondary alkyl halide, and tertiary alkyl halide. Before going to the next classification, I'll show you over here when to call normal, iso, neo, tertiary, secondary, how to identify. This is most important part, children, because if a structure goes wrong, everything will go wrong. Because when you don't know the proper structure of the molecule, you cannot write its IUPAC name, you cannot write the IUPAC name, and remember one thing, every alkyl halide, primary alkyl halide reactivity is different from secondary, it is different from tertiary. That's why if you don't know the exact difference between all these, you cannot understand what the particular reaction. Whenever we are going to write normal chain, all the carbon atoms we write like this. Okay, here chain will be going to continue. Same way, whenever you are going to write iso chain, CH3, CH, CH3. Again, this chain is going to continue. Same way, secondary CH3, CH, CH2, CH3. Same, secondary. Tertiary, tertiary. And the last one, neo. Shall I write here? Is it visible to you? This is neo. This is neo. What the sentence? Remember one thing, all carbon atoms are arranged in open chain, normal. Here CH3, CH3 is iso, CH3, CH, CH2, CH3 is secondary. Then tertiary CH3C, CH3, CH3. For the neo CH3, C, CH3. To the tertiary one carbon atom is linked. It is called as neo. It is called as neo. Same way when they are dealing with the aromatic, when they are dealing with aromatic chain, that time also we can call. That time also we can call with respect to what, children? We can call with respect to phenyl, benzyl, benzo. That also I will show you. After that we will go for second classification. This is called, okay, phenyl halide. Phenyl halide. Benzyl halide. Benzyl halide. Benzyl halide. Benzyl halide. Benzo trihalide. This should be clear to you, children. This is called as phenyl halide, benzyl halide, benzyl halide, and benzo trihalide. Benzo trihalide. Have you observed that? In this case, this is linked with 2 carbon and this is primary in nature. Here we are having 2 halide, correct? 2 halide are linked to same carbon atom. 2 halide group are linked to the same carbon atom. These are geminal dihalide. Geminal dihalide. This is geminal, but it is a trihalide. Geminal trihalide. Trihalide are not there, but I want to show you over here. This is what a simple haloarene. Simple haloarene. This is also mono. This is also mono. This is also mono. But this is di. This is di. This is tri. This is tri. Okay. Come to the second classification. Second classification is what, children? On the basis of nature of hybridization of carbon containing halide group. On the basis of nature of hybridization of carbon containing halide group. They may be classified as carbon hybridized to maybe sp3 because halide group should be linked. Because whenever we are dealing with the classification, we should concentrate on the carbon which contain halide group. We are not worrying about the long chain of carbon atom which are present in a molecule. We are not dealing with the long chain of carbon atom present in a molecule. We want only the carbon atoms which are containing halide group. 1 minute back. Let us start with the next one. Second classification. Second classification, let us start, children. That is, first we have completed on the basis of nature of carbon atom, and the second classification is on the basis of what, children? On the basis of hybridization of carbon containing halide group. Remember one thing, carbon containing halide may be sp3 hybridized, maybe sp2 hybridized, it may be sp hybridized also. Okay, let us move to the next one. On the basis of nature of hybridization. Second one, on the basis of nature of hybridization of carbon containing halide. We are not dealing with remaining carbon. Maybe it may contain 10 number of carbon atoms. We are not at all worried about remaining 10 number of carbon atoms. We are worrying about only the halide group to which carbon atom is linked. Okay? To which carbon atom halide group is linked. So here, very broad classification. Here only we can understand. Carbon containing halide may be sp3 hybridized. Carbon containing halide may be sp2 hybridized. Carbon containing halide may be sp hybridized. sp hybridized. When the carbon containing halide is sp3 hybridized, the topic itself is there, that is haloalkane. These are what we can say, carbon atom. In a simple way we can define that halide group linked to the carbon which is sp3 hybridized. And we know very well that carbon-carbon single bonded molecule are sp3 hybridized, carbon-carbon doubly bonded molecule are sp2, carbon-carbon triple are what children? Sp hybridized. That's why we can say over here in a simple way, carbon containing, carbon is a singly bonded. We can write it as single bonded carbon are there which are containing halide. These are called as sp3 hybridized. They may be alkyl halide, they may be benzyl halide, they may be allyl halide. Allyl halide. Okay. Carbon sp2 hybridized may be haloarene, our topic, or they may be vinyl halide. Vinyl halide. Carbon sp hybridized are what? Alkynyl halide. Alkynyl halide. So we can say that whenever the carbon is sp3 hybridized, carbon containing halide is sp3 hybridized, they may be alkyl halide, they may be benzyl halide, they may be allyl halide. As I said earlier that alkyl halide, it means that alkyl name is derived from alkene. Alkyl name is derived from alkane. One of the hydrogen atom of alkane are replaced by halide group. One of the hydrogen atom of alkane are replaced by halide group. Those are called as what? Alkyl halide. These are common haloalkane. These are what? Haloalkane. How you are going to define? Tell me alkyl halide. Alkyl halide are the derivatives of alkane because we are dealing with mono. That's why we will talk about only about mono. So here we can say that alkyl halide or the haloalkane are the derivatives of alkane where one of the hydrogen atom is replaced by halide group. One of the hydrogen atom is replaced by halide group. Let us take the example simplest. Whenever you are going to write any of the example in the theory paper, always try to concentrate on the example which are simplest for you, easy for you to reproduce in the exam. Even in the earlier theory topic also I said the same. We should go with the simplest example to which we should get a one positive impression on evaluator. So here we can say that CH3Br, even we can write it as C2H5Cl. So it means that when we are dealing with the primary nature of hybridization, when we said alkyl halide, that alkyl halide, this alkyl halide may be primary, may be secondary, may be tertiary. That you need to remember. This may be primary also, secondary also, tertiary also. It may be primary, it may be secondary, it may be tertiary. Only the thing is that carbon should be sp3 hybridized. What makes sentence? Carbon must be sp3 hybridized. sp3 hybridized. Same way when we are going for the next one, benzyl halide. Halide group linked to benzyl group. Already I said to you now how to represent halide group linked to benzyl group. That is cis6H5CH2 is benzyl. Benzyl iodide. Benzyl iodide. This carbon atom means whenever we are dealing with this carbon atom, we can write it as one of the carbon atom is replaced by I. One of the carbon atom is one of the hydrogen atom is replaced by I. Benzyl iodide. Benzyl iodide. Even this hydrogen atom, remember one thing. This also may be primary, may be secondary, may be tertiary. I'll take some of the example after this. Same way, allyl halide. Carbon-carbon double bond, which is next to carbon is containing halide. This carbon is sp3, but the adjacent carbon is sp2. This is called as what? Allyl. This is called as what? Allyl. Allyl halide. Similar way, sp2 haloarene, where halide group is directly linked to benzene. They are called as haloarene. Whereas halide group is directly linked to sp2 hybridized carbon atom, they are called as vinyl. They are called as what? Vinyl halide. Do you know, children? Vinyl halide and haloarene are having almost similar property. Because in both the cases, halide group is directly linked to sp2 hybridized carbon atom. In case of this one, halide group is linked to sp hybridized carbon atom, maybe directly, maybe indirectly. Isn't it? If it is a directly and the indirectly, we are having, like we can call it as, it is alkynyl, but this is having this, sorry. We can write the example like CH, triple bond C and X. This carbon atom is what, children? sp hybridized. This carbon atom is what? sp2 hybridized. This is sp3, but the next carbon atom is sp2. So we can say that the second classification. After this, I will take example. Second classification of the monohaloalkane. First classification is on the basis of nature of carbon atom. Second classification is on the basis of what? Nature of hybridization of carbon containing halide. They may be, carbon may be sp3 hybridized containing halide. Halide group linked to the carbon which is sp2. Halide group linked to the carbon which is sp hybridized. Okay, actually this sp hybridized is not for our syllabus. That's why we are not going to deal with this. But you should know as per your knowledge that this is also possible. In case of this one sp3, sp2. In case of carbon is sp3, they may be alkyl halide or the haloalkane. They may be benzyl halide. They may be allyl halide. What is alkyl halide? Alkyl halide are simple haloalkane. Benzyl halide, where it contains benzylic group. Benzylic group should be there. Next is allyl halide. Allyl halide. Next is related with carbon is sp2 hybridized. They may be haloarene or they may be vinyl halide. If I am going to the example, children, like we'll go to the individual example here because space is not sufficient. I'll write here example. If we are going to take, as I said, that carbon containing sp3 hybridized, maybe alkyl halide, maybe benzyl halide, or maybe what? Allyl halide. Carbon is sp3 hybridized X. First one, like alkyl halide. Alkyl halide. Alkyl halide. Example, let us take. Okay, CH3, CH, Br, CH3. This is primary also, sorry, secondary also, and this is sp3 hybridized also. Correct? Same way, CH3, CCH3, C2H5I. This is tertiary, but carbon is sp3 hybridized. Carbon is sp3 hybridized. Same way, if you are going to take the example, C, Br, CH3 and H. This is secondary carbon atom, but it is sp3 hybridized. What I mean to say that, don't think that halide, this one, the carbon containing halide is sp3. It may be primary, it may be secondary, it may be tertiary also. It may be tertiary, even neo also. If I am going to write neopentyl bromide, neopentyl 1, 2, 3, 4, 5. Neopentyl bromide. This carbon atom is primary and as well as sp3 hybridized. sp3 hybridized. These are what are alkyl halide and as well as benzyl halide. Benzyl halide. So remember one thing, benzyl, even we can call it as benzol, even we can write it as benzo. If I am going to write benzene containing carbon with 3 halide group are there. This is what children, this is all are containing. Here we are having benzoyl trichloride. This is called as benzoyl trichloride. But this carbon atom is linked with what? This carbon atom is linked to this carbon atom. This carbon atom is sp3. sp3. But whenever you are dealing with allylic, okay, if I am going to write the example, you can write some of the examples. Examples will write to identify are they primary, secondary, tertiary, are they which kind of, that will write some of the examples are right here. We'll write example, then we will identify. Not only open chain, if I am going to take closed chain, if I am going to take closed chain, okay, this is double bond and this containing Br. This containing Br. We can call it as what children? This is what a vinyl halide. Vinyl halide. Why? Because this carbon atom is sp2 hybridized. sp2 hybridized. If I am going to take, okay, this is double bond. Here there is a Br. This is called as which type? Allyl. This is allyl because this carbon atom is sp3 hybridized. Next carbon atom is sp2 hybridized. sp2 hybridized. Is it clear to you? So we can say that whenever we are dealing with carbon containing halide, they may be sp3 hybridized, they may be sp2, they may be sp hybridized. Don't think that always we should take only long chain. Only long chain. For example, if somebody will ask you, what is the kind of this one? This one. What is the nature of this halide? This halide. Remember one thing, this is the carbon which is sp3 hybridized. And this carbon linked with all the side 3 carbon. It is tertiary in nature. Tertiary. Okay, so we can say that whenever we are dealing with saturated hydrocarbon, we are discussing about what are primary, secondary, tertiary also. So we can say that whenever we are writing with respect to this one, sp3 hybridized, this is the carbon which is linked with 3 more carbon atom. Correct? Sorry, 2 carbon atom and one side we are having Br. That means that whenever we are identifying the nature of what the nature of carbon atom is containing halide, but 2 side it is having what? 2 carbon. So how many hydrogen are there? 1. It is called as what? Second. It is called as what? Second. Like this we can write with respect to CCl3, benzoyl trichloride. This carbon atom containing halide is sp3. This is sp3 hybridized. sp3. Many of the examples are there in NCERT. This and this example is there. Just to classify the compound on the basis of nature of hybridization. When you are classifying the compound, some of the examples you solve. Then only you will get a clear picture that how to identify. Okay, this is all about the broad classification of haloalkane. What I said in the haloalkane, haloalkane are classified on the basis of number of halogen atoms, mono, di, poly halogen derivatives. Even arene also can be classified. In case of monohalogen derivative, again two more subclasses are there. One on the basis of what? Nature of carbon atom containing halide group. Nature of what? Nature of carbon atom containing halide group. And the second classification, what we said, nature of hybridization of carbon atom containing halide group. What kind of hybridization are possible? What kind of hybridization are possible? Same way with respect to dihalogen derivatives. This also we need to discuss because in the preparation we need dihalogen derivatives. Dihalogen derivatives. Now the point arises that two halogen are there, but they may be present on the same carbon or they may be present on different carbon atom. Different means what? They may be present on neighboring carbon atom or they may be present on terminal carbon atom. That's why we can say that dihalogen derivatives may be geminal dihalide, vicinal, terminal. They may be geminal, they may be vicinal, they may be terminal. Geminal. Gem means what? Group. Gem means what? A group. Two halide are linked to same carbon atom. They are called as geminal. Two halide group are linked to neighboring carbon atom. Neighboring vicinity means what? Our neighbor. They are vicinity to us, we'll say usually. Common terminology. Vicinity means adjacent carbon atom or adjacent house. That is neighbor. Exact neighbor. Exact neighbor, that is vicinity. Terminal means what? A long chain of carbon atom will be there. At the left side. Right and the left side we are having what? X and X. They are called as terminal. Remember one thing. Geminal are usually called as ethylidene halide. Ethylidene halide. If you are calling or not di doesn't matter. It doesn't make much difference. Same way, ethylene halide. Di you can call, you cannot call. That's why whenever we are calling ethylidene halide, we can call it as alkylidene halide. Simple way. Alkylidene halide, and this is alkylene halide. So we can say that whenever the two halide group are linked to the same carbon atom, these are alkylidene. They are linked to adjacent carbon atom, those are what? Alkylene. Whereas when they are linked to terminal carbon atom, those are called as terminal dihalide. Terminal dihalide only. Therefore, whenever we are going to name, remember one thing, whenever we are, this is the common name. This is common name, alkylidene halide, because most of the time they may ask the question related with the common name also. Ethylidene, whenever the ENE comes, don't confusion that, it will be ENE. ENE is not a carbon-carbon double bond. Two halide group are linked to same carbon atom, they are called as geminal. Alkylidene linked to adjacent carbon atom or the neighboring carbon atom, they are called as alkylene, whereas the terminal are called as terminal halide. Okay, this is all about the topic which we need to cover today. Tomorrow what we'll do? We'll go for what? Nomenclature, isomerism. What is left out portion? Nomenclature, then this one, isomerism. Nature of CX bond we need to understand. General method of preparation. Okay, general method of preparation. Up to preparation, we'll try to complete in the first week. Next week, we'll see chemical properties because we are having wide range of chemical properties. Even in the physical properties also, we need to discuss that how they are polar, electronic effect, the dipole moment, that is a polarity, everything we need to discuss. Okay, just I'll say the summary, what we have covered in today's class. We have discussed long this one summary related with how the question paper is going to be designed. After that, we have seen that most of the questions are in the NEET paper or the JEE paper, mains paper. It will be completely from 50% of the paper approximately from organic chemistry. In that, we cannot say that this topic is separate. Haloalkane, haloarenes differ from alcohol, phenol, ether. All topics are like linking topic. We can make a chain over here. Other than that, we said that why we are going to study this topic, that is importance of this topic. Then we have discussed how we are going to classify, on what basis, broad classification we have discussed. Now some of the exercise and text question are there in NCERT book, just to go through it children. Once you solve those questions, you'll get a clear picture to identify allylic, benzylic, vinylic, then common haloalkane, even the sp3 hybridized, sp2, sp, all these you can differentiate yourself. Okay, thank you one and all. Practice well. We'll continue in the next class. So, say,